Hello, so we're back, and this time we have a nice laptop to repair. What about my t-shirt? I got a t-shirt like present from someone. I don't know from where, that's the thing. But check here, yeah? Electronic repair school, and we have a transistor. It's a NPN transistor. It's a yellow one. Not sure if you can see it. Proper nice one. So I just want to say thank you for whoever sent me the t-shirt. It's proper nice, and I will wear it. Okay, so let's go into this repair. What the customer is saying, Zenbook UX534F. The laptop was working fine to the point where need plug the charger, never charged. When I realized the battery was flat and the laptop turned off. My first thing was to try another charger, but still no luck. Doesn't show any charging light. No. Thank you very much for sending this laptop for repair. So what do we know? We know actually, even after the laptop stopped charge, the laptop still worked. So we are expecting a power on the PD controller side. Yeah, I'm expecting the laptop to be good. Now, what we are doing first, let's plug the charger. Wait, we have a round pin charger there? Yeah. Okay, so we do have the plug. Let's switch to 19 volts. Yeah, 19. We need some current. We have 4 amps. That should be fine. Plug in the charger, and it's taking nothing. Nothing. Let's try to press the power button. Pressing the power button, nothing happened. It's taking no current at all. I would say, let's open this laptop and try to have a look inside. Huh? Okay, so the laptop, it's open. Wow, it's looking nice inside, huh? Can you spot anything, any problem? What we are checking first? What we are checking first? The main power rail. Exactly. Let's see what we have there. So on the main power rail, we have 0 volts, and that's not good. So we have the charger plugged in, we have the battery plugged in, and we have 0 volts. Let's unplug the charger. Let's unplug the battery. Yeah, just have in mind this. Yeah, this you pull back this metal thingy, because otherwise you'll break the battery port. And we are switching the multimeter to the resistance. Yeah, let's see if the main power rail is shorted. Here and here is not shorted. And the main power rail, check on the screen, 0 ohms. You can see? 0 ohms. Now the main power rail has exactly 0 ohms, yeah? Means this can be a lucky customer. Can be a shorted capacitor, yeah, can be. So what I will do, I will plug this thingy, because they give me ground, yeah? And I will come with a single probe from the power supply. I will lower the voltage, 0.8 should be fine. We have around 4 amps. Let me grab the thermal camera. And let's see what can be shorted. Can be this a lucky customer? Can be a shorted capacitor? So check here, yeah? Check the input circuit. You can see it here. Pay attention. You have the charging port. You have the first MOSFET, the second MOSFET, and there you have the current sensor. You can see it. So actually we can come with current here. And yeah, it's taking 3 amps. 3 amps, and what is taking 3 amps? Don't tell me that's a MOSFET. It's a MOSFET. I can't believe. Check there. You can see it. Feels bad, man. Feels bad. So actually, the CPU resistance is 0 ohms. Yeah, 0 ohms. Feels bad. Let me see one more time. So it's the second MOSFET, right? Here's the second one. Yeah, the second MOSFET, which is this one, yeah. Yeah, this is, oh, check here, yeah? Okay, I can see now. So someone actually worked here, you can see? Yeah, now it's making sense why the CPU has zeros. So what someone did probably comes with, I don't know what voltage on the main power rail, and current, and they seen heat here, or they feel it. And they remove the capacitor, but it's not the capacitor, it's the chip. This coil seems like someone desoldered the coil. So yeah, we have a dead the CPU. So someone worked here, clearly. Yeah. Feels bad. I mean, the customer didn't tell me, you know, someone already tried to fix it. Yeah, so we took out the MOSFET. Yeah, it feels bad. Let's check now the CPU. So the CPU resistance is 1 ohm. Main power rail still shorted? No, the main power rail is not shorted. You can see, no short. The laptop should come on? Yeah, probably. Plug in the charger. Let me switch to 19. 19 volts. Plug in the charger. And it's taking, you see, it's charging. Or it's coming on. I think it's coming on, right? Yeah, probably. Yeah, the laptop is on. But no picture, probably no vcore. Let's see. We have vcore, like 0.8. Yeah, the CPU is getting mad hot. It's working! That's crazy! How? How? How is working? The CPU has like 1 ohm. It's shutting down, right? Yeah, probably. Yeah, probably. I mean, not sure if it's shutting down because the MOSFET is missing. Okay, let's follow the vcore, yeah? Let's see what is happening with the vcore. 0.8 volts vcore. 1.1, 1 volt. 1 volt vcore. The laptop shut down. 1.1. And it's switching off. One point one. And it's switching off. Okay, you know what? You know what I will do? So the no, it's not staying on. Okay, let me charge the battery. So we're gonna charge the battery. We're gonna help the vcore with the power supply. Yeah, you can do it. Yeah, of course you can do it. And if the laptop is working fine, I mean, I'll order the MOSFET. Or we can get the MOSFET. 1 second. We can get it from the. We can get it from here. I think. No. So the laptop is on, yeah? I'll come with the power supply, 1.1, right? Yeah, 1.1. It's taking 1.2 amps. Check that. Check on the power supply, yeah? Because that's how you check 3 amps. 3 amps. It's still rebooting, right? (1.2), 3 amps, and it's rebooting. Let me raise the vcore a little bit. 1.2. (3.3). I can see the current goes on to the limit on the power supply. Rebooting. Okay, let's check something else here. 1 second. So this coil has 0 volts. That's fine. That's great. That's fantastic. Yeah, we can swap this. We can swap this MOSFET. Yeah, we can do it. Yeah, this is the boosting coil, right? Yeah. It's rebooting. Good. So this coil, we have 0.8. On this coil, we have 1 volt. Here we have, what is here? The chipset? Yeah, chipset. And here we have 1 volt, probably the JGFX. The graphics. Good, so we can swap. Yeah, so check here. What I will do, I will swap this one. I will swap it here. Yeah, that's what I will do. Yeah, let's do it. Let's do it. Yeah, let's swap it. One second. Just a little bit of roasting flux. Perfect. So it's soldered properly on place. Good. Let me cool down the board. So let's see now. Plug in the charger. 19 volts. Perfect. Plug in the charger. And the laptop it is coming on. Let me see the voltage. 0.8. It's not coming on because we moved that MOSFET. No, it's not coming on. We have 0.8 and that's all. It's not starting. Okay, let's do something else. Yeah. Yeah, probably there is a like a power good signal which is checking those power supplies. Yeah, we can't see anything. Okay, let me shut down the laptop. You know what? I can't even shut it down. The laptop is not going off anymore. No. Okay, that's fine. That's okay. That's okay. So plug in the battery. And the laptop is not coming on. That's good. Now let's go with the power supply. Yeah, like 0.8, 0.7 on that coil. Here. And it's taking 200 milliamps. Pressing the power button. Let's see, the laptop is coming on. Yeah. Let's see. It's working. We have picture. Let's see if it's restarting. Let's see. It's loading the windows. We have a BitLocker key, that's sick. But it's working. You can see it. You can see. So I'm supplying that vcore rail with the power supply, and it's working. If I take the voltage, probably it will be fine, because I believe it's checking only on the beginning. Yeah, it's working fine. You can see. So we have skipped the drive. That coil is coming on only when the CPU is boosting the clock, and obviously you need a reason to boost the clock, like when you start the laptop right now. So probably now it will not start anymore. Yeah, it's not starting anymore. Okay, everything is clear. Yeah, I don't need to do more tested on this one. What do we need is to order the MOSFET. Yeah, let me see if I can find it. Okay, let me order the chip, and we're gonna continue with this job after the chip arrives. I have no choice just to order from AliExpress. Yeah, okay. So see you when the chip arrives. So we are like 2 weeks later, and I got the driver. Yeah, let's fit it. Okay, this should be an easy job. Let's solder quickly the chip and see if it's working. So I got 2 chips just to be sure. I have ones for spares. Good, and that's the chip. Let's check the back of the chip. Just a little bit of rosin. And the chip is soldered, right? Yeah, perfect. Perfect. Let's clean it quickly. And the other one. Good, perfect, perfect. Now let's test and see if it's working. Huh? What do you think? It will work or not? Let's see. Wow, still hot. Let me cool down the board quickly. Perfect. Let's plug the battery. Good. Now let's press the power button. Pressing the power button, and the laptop it is coming on. Let's see if we have any picture working. And we have picture. Let's see. Yeah, picture means it's working. You remember it was not working without this chip. And it's loading the windows. Remember, it was asking for, okay, I have to edit the video. It was asking for the recovery key, BitLocker recovery key. So it's working fine. Let's check the voltage on the CPU. So the vcore is about 1.3 volts when the clock is going high. And on my boosting coil, we still have no voltage. Okay, let's see what voltage do we have on this coil. So we have 0 at the moment. 0.7, yeah. 0.7 volts. Yeah, about there. Obviously, the voltage on this coil is going off because, you have to have the CPU loaded in order to have voltage on this one. And those ones are okay. They are idling at around 0.8 volts. Okay, so let's break this down. So the original fault was a shorted DR MOS. Okay, so DR MOS basically are two MOSFETs and the driver inside of a chip. Now, usually I'm used with the gaming laptops. So what is getting wrong with those chips or MOSFETs, if you have MOSFETs, the high side MOSFET is getting shorted. And the moment the high side MOSFET is getting shorted, it's pushing the main power rail into the CPU. But you remember what we check on the beginning, what we check, 0.3 ohms, yeah? And this chip is quite interesting, yeah? Let's have a look at the data sheet. Okay, so those DR MOS, they have something called catastrophic failure protection. And obviously, the protection is about the output. Now, how the chip it will protect actually the output? It will protect the CPU. And you can see it's saying here, when the high side MOSFET overcurrent is detected for 4 consecutive cycles, the high side FET latches off and the fault is asserted to low. This it will not protect your CPU in a case the high side MOSFET is getting shorted. But the low side FET is turned on until the zero current detection. So you understand how this is working. Pretty smart. So on the high side MOSFET here is getting shorted, the low side MOSFET is getting turned on. And on that moment, probably the low side MOSFET it will get shorted, but anyway, it's all about the output, yeah? So whatever is connected on the output, it will be protected on this way. I didn't found those kind of monolithic drivers, MP, on many laptops. But I'm quite impressed about those little chips. I mean, we found one here, and the CPU was protected, right? You can believe actually last week I found same, it's not same, it's a little bit different, but same capsule, same everything. I found on a Dell Alienware laptop. The chip it was shorted, but the CPU was good, so I just replaced the DR MOS and the laptop was fine. So yeah, it looks like those all-in-one thingies, they are quite good. Now, it's one more thing about those DR MOS. If we are checking the resistance to ground, 0 ohms, 0 ohms, 0 ohms. But is no voltage here. So how is 0 ohms there? You can see, is no voltage because the laptop is off, obviously. Well, actually, those DR MOS are holding the output down to ground when it's not supposed to be on. That's the reason why we have 0 ohms. Yeah, that's the reason why we have 0 ohms. But if I disconnect the charger and if I disconnect the battery, yeah, pay attention here. Actually, now I can check the CPU resistance, which is 3.3 ohms. It is pretty weird because after we removed the MOSFET, you remember, we had like a little bit over 1 ohm. So this is strange. Why now is 3 ohms, but when we checked then, it was like 1 ohm. But it is expected. I mean, the internal resistance of the CPU is changing on based on a lot of factors. So even the heat, we have 3 ohms. Check there. Check there. 2.4, 2.3, 2 ohms, 1.8, 1.7, 1.6. So yeah, the internal resistance of the CPU or any chip doesn't matter. It's affected by heat. Yeah, it's like 50 degrees. It's not that much. But that's the reason why we checked and was like 1 ohm, because we desoldered that and the board was hot, and that's the reason why we had 1 ohm. But this CPU has like 3 ohms. Now, if you have this laptop to repair, I will give you the coils measurements. So like how I said, the CPU like now is 2 ohms, so must be around 3 ohms if it's cold. This one 3.2, it's a little bit higher. Here we have 32 ohms. Here we have 9.8 ohms. Here we have nothing. This is the charging coil. Here we have nothing. Here we have nothing. And here we have 118 ohms. Possible to be the RAM memory power supply. Okay, good. I'm happy I helped this customer. I did found on small laptops, shorted MOSFETs, but most of the time, just by replacing the shorted MOSFET, it will fix the problem. But like how I said, on those small laptops, on a gaming laptop, when the high side MOSFET is getting shorted, usually it's getting dead whatever is on that power rail. I mean, even the CPU or the GPU. But those MP monolithic chips, I'm quite impressed. Okay, lol, I got scared. So actually, this is a screen. I didn't know that. This, it's touchpad, and on the same time, it's a screen. I think I seen one more like this. Lol, I was like, how can be pictured here? That's crazy. I can't show you because it's a private picture on the screen, but actually this is a LCD screen. Pretty nice, pretty cool. Okay, so I'm gonna stop now. I will say thank you for watching. Just like, subscribe if you like the video, and see you on the next one, right? Have a great weekend. Bye.